Make a chart of the first 5 shakes that shows a growth of a skeeter population with an initial population of 5 and a growth rate of 120%. So what are we going to have for shake number 0?
5.
Okay. Now, how are we going to determine the amount for the next shake? Brooke.
So it says 120%, wouldn't it be 1.2 times 5, or 5 times 1.2 to the first power, or 2?
No, but you're on the right track.
Well, you have to add 1, so it'd be 2.2 times 5
There
to
you
the
go.
first power.
There you go.
Oh, yeah.
So, yes, we have to take the growth rate, change it to a decimal, add 1 to it to get the factor. So we're going to take our previous population, multiply it by 2.2. So now what is our population?
11.
Okay. 11 times 2.2 gives us 24.2 times 2.2. 53.24 times 2.2 gives us
117.128. So much robots.
and 117.
257.60.
Thanks, Hippie.
Yeah.
All right, now we need to sketch it. So what are we going to put on the x-axis?
The population. I mean the shake number.
Okay. So we're going to start with what number? And go up to
5.
She said 0.
what are we going to put on the y-axis?
The population.
Population.
Good job, Hannah.
And we need to go up to what for the population?
267.68.
So what increments do you want to do?
50s.
50s? I think we could do
25.
We could do 25s. We could do 20s too.
25.
So 0.
25.
This is gonna be 20, but I'm not gonna label that one. And then 40, 60, 80, 100. Did I? 2.
Yeah, you did that wrong.
Yeah.
I did it wrong?
20 to 100.
Oh, I did. Awesome. No, I didn't.
Yeah, you
Yeah,
did.
you
You're
did.
different 100 to
To
200.
200.
That's 160.
Yeah, it is 160.
Oh.
Oh.
I
Oh, it
have
looks like
40,
100.
80, 120, 160, 200,
It looks like
240.
100.
I know.
160.
Because my 6.
What's 140?
Yeah, but
140 is implied by
Did you
this
go
one
from 80
here.
to 100 though?
I have 0, 80, 100, 120, 140, 160, 180, 200,
Alright, I'm
220.
just going by 20.
Yeah, you're
That's what I said. I'm doing 20s, but I'm not labeling every line.
Oh.
I have why would you
Yeah.
confusing? So that's not great.
I didn't mess up anything.
Sorry.
That's your math.
All right, so what's the first ordered pair that we're going to grab?
0 and 5.
0 and 5. Next ordered pair?
1 and 11.
Yes. Next one?
2 and 7.
Yep. Next one?
53 and 53.
Yep. Next one?
4 and 117.
And the last one.
5 and 227.
Good. B says, write the equation in the form y equals a times b to the x, where y stands for the
Population.
Yep, total population. The A stands for the
Initial population.
initial population. The B stands for the net growth rate. Vector. Very good. Bless you. And the X stands for the shake number. Nice. So, let's write it. Y equals. The A stands for the. So what is our initial?
5.
You got such a good class,
I know, I think awesome.
You suck.
And
3 times the size of your 6 times. You're so quiet.
2.2 to the X. All right, it says, use appropriate technology to create this graph and check it. So, turn your calculators on. Do you have the graph calculator? Picture Y equals.
Where is that?
Y equals right here under the stat plot.
Oh, I found it.
I don't have one.
And type in your equation. 5 times 2.2 caret X.
How do you hit X?
The X is right next to the green alpha key.
Yeah, see, I don't have that on my calculator.
I don't have it.
Where's
Oh,
the
I
X?
Next to the.
Oh.
Next to the green alpha key.
Is that it?
How do I know?
Then do we hit enter?
Under the second.
Before you hit enter,
Big X.
what?
The big X.
It's a big X. This key right here, next to the green alpha key. All right. There's the second key from the left under the window. It says window. Hit window. And what we want to tell our calculator is the window that we used on our graph paper. So, what was the maximum value that we put on the x-axis? What is the maximum value?
5.
57.78.
What's the maximum value that we put on our x-axis?
5.
5. So choose a number, a couple numbers larger than 5, like 7. And we went up by increments of 1s, so your x scale on your calculator would be good for 1. Your maximum for your x or for your y-axis was what? 280. And we went up by increments of 20. Now hit the graph key. It's all the way on the right, under the window.
It's pretty special.
Arrow. And then. Wait,
Gotta
what's
go.
the XRES?
Gotta go. Hey, Mallory,
Mine looks like the one on the
Oh man, I hit clear.
I have squares.
Mine didn't work. Mine didn't work. Mine gave me a number. My calculator's dumb.
Okay, your pot sideways.
Mom, do you have a chance?
And your window.
That means.
I swear I did.
Wait, Tyler, what was you reading? Abby. What was he reading?
One movie looks exactly the same.
That's
What?
What's the
your wrist. You've got your
What is it?
Put on your muscle.
Now, are you going to the play?
No, because I'm going to be out of town this weekend.
What about next weekend?
What does Lizzie have this hour, so I don't have to go down to my office?
I should know, right?
I know I should know too. I want to say
Or
it's
name,
name.
but I'm not sure.
See if I'm right.
I just don't want to rock out.
No!
Sorry, you guys, to interrupt.
You're going to be on recording. You're recording on the board. You're going to be recorded.
I know we're recording, right? Yes, I know we're recording. Okay, so does our graph that we created on the grid paper look the same as what we've got on the calculator?
Yes.
Okay, good. All right, two of your classmates have used a spreadsheet to model the growth of a population of skeeters.
Right.
The initial population was 8. After 9 shakes, the total population was 2,097,152. What growth rate did they use? So, we're trying to find the growth rate. So, we need to use our equation. Y equals A times B to the X. When we're asked to find the growth rate, which one of those letters are we looking to solve for?
B,
The B. Why?
because that's one less than one more than the growth rate.
Factor is one more than the growth rate. All right, so let's fill in what we know and solve for the B. So, the Y represents the what?
The total
Population. So what's our population?
2,000,000. Oh, no, it was 2 million.
2,097,000 equals, what does the A represent? Times, we're looking for the B, so we're going to leave the B there. Do we know how many shake numbers?
9.
9. It tells us right here after 9 shakes.
I knew that.
We're solving for the B. So we're trying to get B by itself. So what do we need to do?
Divide by 8.
Divide by 8. So divide both sides by 8. It cancels on the right, and we have B to the 9th equals what? Okay. How can we solve this?
Divide.
Divide by 9.
No, because it's raised to a power, isn't it?
Yeah.
Times by negative 9.
Times by negative 9? No?
Wait,
That number is square root in there. Divide by
Divide by
Bless you.
divide by 9 to the 9 to the 9th power.
Sorry, just put random numbers in until you find it.
You could do that, but actually we will in Ag 2 talk about if you multiply by the inverse power, it will also solve it. But for now, nice Wyatt.
Being smart.
You are, yes. For now, we will put in different numbers and guess and check. So, guess and check. So start with, is it going to be 1 to the 9th power?
It's
I just guessed.
It's 4 to the 9th. I got it on my first try.
All right, good job. All right, so 4 to the 9th power gives us 262,144. So, the B value is equal to 4. I'm asked to find the growth rate. So what's the relationship between the growth rate and the factor?
Just 1.
What?
1 decimal. Or
So to
1.
find, the factor is 1 what? 1 more. So the growth rate,
It's 5.
no, it's 1 less.
It'd be 3.
Oh.
It would be 3, which is what percentage?
Oh, I thought we were adding percent. Yeah.
Buyers, I'm gonna kill them.
The relation.
Dude, she's kicking the thing and it's shaking that anything.
All right, let's be still.
I got a support.
I can see you bouncing back there.
Yeah, that's right.
The relation y equals 4 times 2 to the x models the growth in a population of skeeters. Describe the values of the domain and the range in the setting. So, the domain. All right, girls. The domain represents what?
X.
X values. And what did we graph on the x-axis? Shake number. The range. Population. Which values are these? Y values. What's unique about the Y values in the population? What's unique about these numbers?
They're all divisible by no.
Just the populations in general. Can you have any values for a population?
Yeah.
Yeah?
Yeah.
Any
Except for a negative.
except for negative Y.
Because you can't have a negative person.
Okay. So that means that your population is always going to be
A positive.
positive. Is this relation a function?
Yes.
For every x, there's one y, and it passes the vertical line test?
Yep.
Okay.
Just me.
Right in the middle of recording.
We're doing notes right now. All right, find the size. Sorry, the two equations below represent two different populations of skeeters. Graph both equations on the same set of axes. The question asks you, when will these populations be approximately the same size? So what are we looking for these equations to do?
Cross.
We are looking for them to cross. So it's asking for the same size, so we want them to intersect or run into each other. So on your calculators, y equals, clear out the previous one, type in 20 times 1.5 caret x. Is this your name?
Yeah.
Okay. Arrow down. And we have 2 times 2 caret x. Hit the graph key. And we want to see where these lines cross, these graphs cross. Here's the first one and the second one. Do we see them crossing?
No.
All right, so that means we need to do what?
There's our graph.
Yes, make the window bigger. So let's increase our x a little bit, maybe double it to 14, and maybe double our y max. That would be 560. See if we can see it with that window. Hit graph again.
Okay.
What's that?
I got it.
You got it?
Yeah.
All right, they're intersecting. So, can we tell exactly where they're intersecting?
Yep.
No. What's really cool is the calculator will tell you though. If you hit second and trace, a menu will pop up. Second and trace. Now from this menu, what do you think we want to look for?
Where's it intersect?
Intersect. So hit the 5 key. Now it's asking first curve. We don't want to know just about the first curve. If you hit enter, it'll say second curve. We're not interested in just the second curve. Hit enter again, and then enter again. So you've hit enter 3 times. What does it say down at the bottom in the left-hand corner there?
Intersection.
It says intersection. What's our x value?
8.
8, and our y value is?
513.
So what exactly does that mean? The 5. I'm sorry, the 8. 8 what? 8 shakes, and the 513 is the?
Population.
So that means that after 8 shakes or years, how many people will they both have? 513. Example 5. Find the size of each population when x equals 0. So we have y, for the first one, y equals 20 times 1.5. And it says when x equals 0. So that means we're going to substitute 0 in for the x. What's 1.5 to the 0 power? What's 1 times 20? 20. Second equation, y equals 2 times 2 to the 0. What's 2 to the 0 power?
1.
1 times 2 is?
2.
What do these values represent in the equation? Initial values. Anytime you raise it to the 0 power, that's your initial value. The table below shows a population of skeeters in a container after each of 5 shakes. Write an equation that could be used to describe this data. Your equation may not describe the data exactly. So how do we find growth rates? New minus old divided by old. So after shake 1, what's our new population?
8.
Minus our old divided by gives us 5/3, which is
1.6.
okay. Shake 2, what's our new? Minus our old, which is
8.
divided by 8. We have 13 over 8, which is 34 minus 21 divided by 21 gives us 13 over 21, which is shake number 4. What's our new? Minus divided by gives us 56 over 34, which is, and 240 minus 90 divided by 90 gives us, okay. Do we have the same growth rate for each shake? Except for 1. So how do we find an average growth rate? Very good. So our average growth rate, we need to add 1.6 plus 1.6 plus 0.6 plus 1.6 plus 1.6 and divide it by 5.
1.4.
So that means that our factor is 2.4. So we need to write the equation.
Not like that.
Y equals
3.
times
2.4.
to the x. There's your equation.
Gosh, those notes took forever.